Hello, my name is Deidrah Carrillo, and I am a student studying chemistry at the University of Texas at El Paso. As the first of my family to enter the university, I had the whole world of opportunities ahead of me. This led me to be very confused about what career path I should take. The one thing I was certain about was my desire to learn and teach chemistry. I've always been curious about the world around me and being able to learn about molecules, atoms, and electrons. My time here at UTEP, I've had the wonderful opportunity to be a part of the Maximizing Access to Research Careers and Research Initiative to Scientific Enhancement undergraduate research programs. These two undergraduate research programs led me to Dr. Panel's Organometallics Research Laboratory. My work in the panel lab consisted of synthesizing and studying new organometallic compounds, in specific creating mixed metal molecules with a silicon linker. Chemistry can be a lot of things: organic, thermodynamic, analytical, and quantum. But in the heart of all reactive science are electrons, and they are what interests us when creating our compounds. One of the main focuses in the panel lab is working with silicon. Silicon is a group 4A element, right below carbon. Being right below carbon, it often shares similar bonding abilities, but as well as being below carbon, it has access to more electrons and higher energy orbitals. This is what gives this organic-like element its metalloid and semiconductive properties. Transition metals are commonly known for their luster, malleability, conductivity, but to chemists, they are D-block elements, which basically makes them reservoirs of electrons. Combining the electronic properties of silicon and transition metals, we experimentally test the extent of how willing atoms are to sharing electrons intramolecularly. In the panel lab, I have learned many skills, one of which is how to handle air-sensitive materials with the utilization of a Schlenk line and inert gas, because, well, metals are often prone to oxidation. I have also learned purification techniques which involve chromatography, distillations, and sublimations. I have learned how to use proton NMR, carbon NMR, and phosphorus NMR, as well as IR spectroscopy, UV-vis spectroscopy, and X-ray spectroscopy. One summer, I traveled to the University of Georgia in Athens, where I worked with Dr. Greg Robinson on N-heterocyclic carbines and main group chemistry. It was here where I was able to contribute work towards a scientific paper which was published later that year. I've also had the opportunity to travel across the Atlantic to Toulouse, France. I was in a new country where I knew no street, no person, nor the language, but what I did know was how to do the science I went there to conduct. I went to the University Paul Sabatier, where I worked in the LHFA and was a part of the LBPB group, all of which was overseen by Dr. Deidrah Carrillo. The work I did consisted of synthesizing new amphiphilic compounds, in specific, new frustrated-Lewis pairs, FLPs. The idea was to create FLP ligands that would work as catalysts and small molecule activators. My undergraduate experience has all been a great foundation towards my goal of obtaining a PhD in chemistry, to not only satisfy my personal curiosities, but to contribute fundamental chemical knowledge to the scientific community. With a PhD in chemistry, I wouldn't only want to do research. I would also like to do what so many have done for me through this career journey. I am a first-generation student, and half my undergraduate career I felt lost, and it wasn't until I met great professors like Dr. Panel, Dr. Robinson, and Dr. Boissou, and so many more, who have inspired me to stay curious and find open doors to grow. I would like to do the same for future students who love science and have a passion for it. Thank you for listening to a little bit of my story. I'd also like to thank my friends, family, and those professors. I wouldn't be where I am today if it wasn't for their love and support. Thank you.